Welcome to course 5 of the Lunch and Learns. My name is Josh, and I am one of the cyber range engineers at Tech Data. Typically, you probably have John presenting these Lunch and Learns to you, but we thought for this one, I'd go ahead and do that. So today, we're going to be covering the fundamentals of the internet. And really, the purpose of this Lunch and Learn is to review the key concepts and technologies of the internet. So the internet is made up of routing and switching, some firewalls, different types of IP addressing schemas. This is going to be a gentle introduction. Later, we'll talk about how the internet and networking really is very complex, and there's architects and engineers in this field or that specialize in networking because of how much there is to know. The internet is made up of networks. So we're going to primarily approach this course about the internet through the lens of what are networks or what make networks up. So the first thing to start with when talking about anything in regards to the internet or networks is the OSI model. If you've ever done a course around information technology, security, or whatever, there's always a course on networking, and they always talk about the OSI model or the TCP/IP. OSI model is what's typically used. And when we talk about the OSI model, there are 7 layers that we are talking about in the way that data flows through a network. So you have your physical layer, that's layer 1, your data link layer, layer 2, your network layer, layer 3, your transport layer, layer 4, your session layer, layer 5, presentation layer, layer 6, and your application layer, layer 7. I'm not going to go in depth into what each layer does. We have provided on the right side of your screen some information about each layer. There's another layer, though, that's not mentioned on here that sometimes in IT we joke about, and that's layer 8. It's typically the chair to keyboard interface talking about the user. It's not a real layer used in the OSI model, but it's a little joke that we like to use and be jovial about. So one of the ways in which you can remember the OSI model is through please do not throw sausage pizza away. Very simple. The beginning of each of those letters tells you which layer you're talking about or thinking about, whether it's going to be layer 2, layer 6, layer 7. An easy way to remember physical through application. Please do not throw sausage pizza away. Now, you may ask, why is networking relevant to me, an individual who's interested in security? Well, security and networks, they go hand in hand. There are network security engineers, right? If you're just focusing on being a penetration tester, you're going to have to know how networks work. If you're going to want to be a defender and you want to protect networks, well, you're going to also have to understand how networks work, and how data flows. So almost all cybersecurity job interviews are going to have a question around networking or your ability to understand it. So again, gentle introduction. There are some resources we'll provide later that will help you through learning and understanding networking. And so the OSI model is where we begin. Moving forward, we talk about IP addressing. How does data flow in a network, or how does data flow from my computer over the public internet to Google or Facebook or Instagram or Twitter, whatever you like to use? Well, there are private and public networks, right? There are private and public IP addressing. So private IP addressing is related to IPv4 or IPv6, can also be used publicly, but the routes and the IP addressing schemas are different. IPv4 can have many different types of CIDR notation. CIDR notation is simply a classless interdomain routing system, right? It talks about whether you have a class C or a class A or a class B, right? Classes again, beyond the scope of this lunch and learn, there is a lot to know about how to set up different classes, how to do CIDR notation, how to split up networks, how to split up a /16 or what a /24 is. Those are all classes or CIDR notations for IP addressing. So we've given some information here about what IPv4 is. I would briefly like to point out that IPv4's address space is 32 bits, right? There are a total of 4.3 billion addresses that must be either reused and masked. And IPv4 is a decimal notation, and you'll see how this differs from IPv6. The reason why we have IPv6 is because the available addresses began to diminish with IPv4, especially when it came to the public internet, because of the amount of devices that we have on the internet today. Furthermore, IPv6 also provides some newer features related to quality of service, but we can talk about that later. So when you're working with Google's DNS 8888, that is an example of a public IP address that is IPv4. We've given some examples of private network blocks there, class A, class B, and class C, 192.168, class C. So that's IPv4. Now, IPv6, again, I said IPv6 came about because of the exhaustion from IPv4, or the number of usable addresses was no longer there and we needed a new solution. So IPv6, the space is 128 bits, and IPv6 has, I think it's like, there we did the calculations 2 to the 128 power. There's a lot more unique addresses available in IPv6 that every device itself can have a unique address. Now, we talked about how IPv4 is a numerical decimal notation, right? 192.168.5.1 or whatever. IPv6 is alphanumeric hexadecimal notation, and you'll see that below with the examples we've provided. And as I mentioned before, the IPv6, the flow level field that's in the header portion, it identifies that packet flow for us. So this can help direct packets to the router appropriately to make quality of service more efficient. So that's IPv4 and IPv6 in a nutshell. Again, there is a lot more that you can learn about IPv4 and IPv6 addressing. The most important thing to remember is the differences between the two. IPv4 has 32-bit addresses. IPv6 has 128-bit IP addresses. IPv4 is dot decimal notation, whereas IPv6 is alphanumeric hexadecimal notation. And IPv6 is leveraged because its addressing schema allows for each device to have a unique address. Moving beyond IP addressing, we can talk about DNS, or the domain name system. So we talked about addresses. Well, when you go to google.com, that is associated to a public IP address. Now, for you as the individual to remember what the public IP address is of every site you want to visit would be very cumbersome. So the domain name system provides us what we like to call a phone book for the internet. I want to go to google.com. The domain name system will translate google.com to its public IP address. If I want to go to facebook.com, the domain name system will translate facebook.com to its associated public IP address, and so on and so forth. It provides an easy way for us to use human readable or just the English language or a foreign language to translate the website we want to go to its public IP address. Beyond public, it can also be used for private. So in your local area network or in an organization, different systems, whether they're user computers, whether it's intranet websites, whether it's servers, they can also have their own domain name system or DNS record that associates their private IP address with a name. We gave an example of Bob's laptop, right, at this organization.local. You could have, a different, a more random string that is associated to, this is a Windows laptop and it's running version 10 and it's part of our domain of X organization.local, so on and so forth. This translation between IP addresses and domain name system names can help through doing different types of log analysis, launching different types of investigations. DNS also helps with different types of threat hunting measures and also threat intelligence, because sometimes your DNS record can change to its associated public IP address, right? Or even private IP addressing. That's why if the IP address changes, sometimes your DNS record won't change, but it can get updated for the new address that's being used. There are also things in DNS called reverse lookups. This simply just translates an IP address to a domain name. If I don't know what the domain name is that's associated with an IP, I can do a reverse lookup. In our Nmap Lunch and Learn, we did talk a little bit about dig and different types of lookups that can be used in some aspects of DNS. If you want to see a demonstration of that, I encourage you to go back and look at our Nmap course. But there are tools in Linux like dig and NSLOOKUP that can be used to do both reverse lookups and your standard DNS lookups as well. Beyond DNS, when we talked about IP addressing, one might ask, well, how do I get my system to have a specific IP address? Well, you can do it statically. You can assign it statically. So if you have a class C address with a /24 and you want your laptop to have a 192.168.1.5 address, you can go into its network configuration and you can set that statically. But in larger networks, it can become more cumbersome, especially when we're looking at, the accessibility between an internet service provider and a user at home. The internet service provider could lease you a static address, but it's going to be easier for them to use DHCP to lease to your modem through DHCP its address space. So the dynamic host configuration protocol simplifies the issuing out of IP addresses. So as more devices are added, as networks begin to get larger in scale, going into each device and statically assigning an IP address can be cumbersome. Now, DHCP uses a standard known as DORA. If your DHCP is not doing DORA, it cannot consider itself a DHCP server. It is very important that this protocol is followed because that is how the address is issued to the device that is looking for its IP. The requesting device discovers the DHCP server. The DHCP server offers it a lease. The server requests that it receives that, and the DHCP server acknowledges that request, solidifying that the IP address it initially offered and then was requested back was given and leased out. This helps to ensure that your devices are all receiving unique IP addresses within a network, whether it's private or public. So if you ever look at DHCP from a packet level using Wireshark, you will see the DORA protocol in the DORA standard in action. So that is our DHCP. So beyond DHCP, Really, there's routing and switching. When you break down networks, you break them down to routing and switching. They are different functions, but they are both important for the function of a network, right? A switch switches data packets between devices on the same network, and a routing device routes packets between different networks. So a router would be used to route traffic from a private network to a public network, but to move packets between the same network, you would use a switch. So switches are used to connect multiple devices on the same network within a building or a campus. They act as a controller. It's a very good way to think about it. Routers are used to tie multiple networks together, and your router allows your home network devices to talk to the internet. We were just talking about that. So the route, think of your switches as controllers and your routers as dispatchers, because the router will then choose what is the best route for this data or for this packet to travel. Some routers do have built-in functions like a firewall or a VPN, but it's typically better to have a device that its sole purpose is to do this aspect of network communications, because it then, for small businesses, right, you can buy all-in-one devices that do many different things, but larger enterprise environments, you're going to want devices that do specific things. This is just because, you want a device that does what it's supposed to do well versus trying to do all the things and then doing nothing really well. That's ultimately my opinion. But so routing and switching are the fundamental aspects of network communications, where switches switch packets between devices on the same network, and routers route packets between different networks. It's important to remember that. So part of networks, and this is a little bit where we begin to get from networking into the aspects of security in networking, because, in some organizations, firewalls are security's responsibility, and in some organizations, firewalls are a networking responsibility. This is why you have network security engineers. But it's always best that whether you're on the networking side of the house or the security side of the house, you understand what the purpose of the devices are and what they're doing. So firewalls are really what we like to call, they make a walled garden, right? So anything beyond your perimeter, outside of your perimeter firewall is outside of your walled garden, and anything inside of your perimeter firewall is inside of your walled garden. And so a firewall monitors and controls any incoming and outgoing traffic based upon an access control list or predetermined rules, right? So your security operations center, those analysts, those engineers may then communicate with the architect that a new firewall rule needs to be made based upon an ongoing incident or event, based upon some threat intelligence or some blog reports from groups like McAfee or Fortinet or Trend Micro. They may say, hey, this type of traffic is trying to come into a network and it's known malicious. Here's a rule you can write to block this traffic or drop this traffic. That's a way in which firewalls can work. Later, we'll talk about IDS and IPS and another way in which it can provide more visibility into the flow of network traffic. But firewalls, the simple example is you may have a web server with several open ports, let's say 10 open ports, and you don't want all 10 of those open ports to be accessible from the public internet. Well, you may create a firewall rule that only allows incoming traffic over port 80 and 443. Those ports, 80 and 443, are used to say web traffic only, 1 over HTTP versus 1 over HTTPS. So firewalls are an essential tool in limiting unwanted traffic on your network. There we have some guidance in regards to a best practice about setting up your ACLs. Now let's talk about the different types of firewalls, and I'm not going to go too in depth on this. I want to stay high level, but it's important we talk about stateless and stateful firewalls. Stateless firewalls use clues from the destination address, source, and other key values to assess whether threats are present, right? They then block or restrict what is deemed untrusted. So it looks at the information that's flowing through it and says, are there any clues about where it's going, where it came from, or any other values in the packets that is possibly is malicious and untrusted and needs to be dropped? Now, a stateful firewall on the other side monitors all aspects of traffic streams, their characteristics and communication channels. So stateful firewalls are very different than stateless. They each have their pros and their cons, but one of the things that has now come onto the scene is, or one of the things that many people are talking about, is next generation firewalls. And briefly, before we go into what makes up next generation firewalls, it's important to talk about the firewalls that I've been mentioning are related to networking devices. There are host-based firewall systems like the uncomplicated firewall on or UFW on Debian-based Linux systems. There's also IP tables. UFW is often referred to as a front end for IP tables, but you can, beyond network firewalls, also have host-based firewalls. So next generation firewalls typically include all of what we talked about previously, but also IDS, IPS. So what's IDS and IPS? Well, the D in IDS stands for detection, and the P in IPS stands for prevention. So the difference is one detects the bad happening, the other prevents the bad from happening. This is all based upon signatures. So an IDS device uses signatures to look at suspicious and malicious network traffic and policy violations, and then hopefully is alerting your security operations center, or those logs are being sent into your secure your SIM, your security incident and event manager. Hopefully, right, that traffic's going there so it can be correlated. So IDS is simply alerting. An IPS, or intrusion prevention system, is now blocking based upon the signatures that are written. So if there is something that is malicious or suspicious in your network traffic, and it is violating the signatures and policies you have put in place, that traffic will be blocked. Now, IPSs can sometimes block legitimate traffic based upon how it looks. So some organizations are very hesitant to use it, but if you work to finely tune your IPS, it can benefit your organization very well, right? So next generation firewalls, furthermore, now provide deep packet inspection as well. So it looks for patterns in traffic. The IDS, IPS systems are all included in next generation firewalls. It provides those different states, but furthermore provides deep packet inspection. So to sum it up, there is a lot more to learn about networking than I've talked about. I've mentioned this early on, I'll mention it again. There are network engineers that specify in the engineering of networks. There are network architects that specialize in the architecture of networks. So the foundational and intermediate knowledge that we've provided, really, we've stayed foundational, but this will help you understand more of what you need to learn about networks, and it will help you along as you learn about cybersecurity. So a gentle introduction, because I don't want to bombard you with all the information that there is to learn about networks, but there are additional resources you can use. RangeForce is partnered with the Tech Data Cyber Range. They have modules related to networking and understanding the OSI model. how networks work, the differences between firewalls, IDS, and IPS systems. Cyber Area IT is also partnered with the Tech Data Cyber Range. They have modules for getting certified in networks for your Network Plus or a CCNA. Very useful information there. And then additionally, TryHackMe, not partnered with the Cyber Warfare Range or Cyber Range at Tech Data, but they also have a learning track that can help you learn more about networks. So that's all we have. Thank you for participating and listening for this Course 5 Lunch and Learn. Hopefully you've learned about networks, how they function, how they work, and you understand more about the internet. Have a great day.